Okay, we are now ready to correct activity 2, parts A and B. It says for problem A, list 10 numbers that are divisible by 6 and write a rule to determine if a number is divisible by 6. So what I've done here is I've just listed the first 10 multiples of 6. You could have chosen any numbers you wanted to that were divisible by 6. I just chose to list the first 10. Now, you need to really look at these numbers carefully to see if you can find a pattern as far as how to determine a divisibility rule for 6. If you look at these numbers, you can see that the sum of the digits is always going to be divisible by 3. 6 I can divide by 3. 1 plus 2 is 3. I can divide 3 by 3. 1 plus 8 is 9. 9 can be divided by 3, and so forth. Another thing that you'll also notice is all of the numbers are even. So the sum can't just be divisible by 3, but the number itself, if it's divisible by 6, will always be an even number. Remember, even numbers end in 0, 2, 4, 6, or 8. If both of these rules are met, then the number is divisible by 6. It has to be both, not just one or the other. Notice the word and. Okay, let's take a look at B for problem 9. Okay, once again, I just chose to list the first 10 multiples of 9. And if I look at these, you'll notice that the sum of the digits is always divisible by 9. So, in this case, I have 0 plus 9, it's just 9. 9 divided by 9 is 9, or excuse me, is 1, so it works. 1 plus 8 is 9. 9 divided by 9 is 1. Let's skip down to 72. 7 plus 2 is 9. 9 divided by 9 is 1. Now, one thing you may be thinking is, oh, the numbers must always add up to 9. This is not true. Sometimes you may have a different number. Let me write another one down over here as an example. Okay, let's say the number I had is 261. Okay, now in this case, once again, actually, if I add those three numbers, it still adds up to 9. It doesn't have to, but in this case, that wasn't a very good example. It still does. Let me give you a different one. Okay, how about 585? Okay, this one will work. Notice, if I add these three numbers up, 5 plus 8 is 13, plus 5 is 18. Then 18 divided by 9 is 2. So our rule still does work. The digits don't have to add up to 9, but it does have to add up to a number that is divisible by 9. Okay, now on this page I have a divisibility rules chart. If you look in your green math resource packet, you're going to see another chart. It's not the exact same one as this, but it gives you the same information. So you do not need to copy this down into your notes at this time. Okay, for problems, if you're looking to see whether a number is divisible by 2, 5, or 10, you're going to look at the ones place. For 2, if the last digit's even, it's divisible by 2. For the number 5, if the last digit is 5 or 0, it will be divisible by 5. And then for 10, if the last digit is 0, it will be divisible by 10. Okay, now in 3, 6, and 9, if you check the digit sum, and remember sum means you're adding the numbers together, if you add up the numbers or the sum of the digits in a particular number, if the sum of the digits is divisible by 3, then it is going to work. If the number is divisible by 3 and 2, then 6 is a factor. And if the sum of the digits is divisible by 9, then you know that 9 will be a factor. And then the last one. If the last two digits form a number that's divisible by 4, we haven't talked about the rules for 4 and 8 yet, but if the last two digits are divisible by 4, then 4 is a factor. And if the last three digits are divisible by 8, then 8 is a factor. Those two rules are a little bit trickier to follow, but it does still work. Okay, please take a look at your assignment. If you open up your workbook to page 18, problems 1 through 6, you need to list the factor pairs. Please remember to start with 1 times the number and then work your way up. So I'll show you the first one. For 6, I'm going to do 1 times 6 and then 2 times 3. So these 1, 6, 2, and 3 are the factor pairs for 6. So that's how you're going to complete 1 through 6. And then 7 through 12, you need to make a factor tree for the prime factorization of the number, and then list the numbers out from least to greatest. And then number 13 has a couple of word problems.